Previous example, the example is cash flow of project A, 3000 for all the all 5 years cash flow, and and for project B 1000, 2000, 3000, 5000 and 6000 respectively, and the cost of capital is 10%. The question is asking make a decisions for project if independent or project is mutually exclusive under IRR. So now let's follow the step. Calculation of IRR of project A. Step 1, which is payback period of project A, which is payback period is equal to initial cost divided by annual cash flow. We know that initial cost is 10,000 pound, 10,000. Then annual cash flow for project 1 is 3000 for all the 5 years, so that means 3000 is here. Then we get value here, payback period 3.333 years. Now let's find out the discount rate for interpolation. Step 2, discount rate for interpolation. How do you find discount rate? This 3.33 years, if you look in the present value factor annuity across the 5-year period, so number of period is 5 and year is 3.33 years, that this 3.333 lies between 3.3522 and 3.2743. So that means we have two present value annuity factor. So let's find out the actual lower rate plus present value interest factor annuity at lower rate minus payback period divided by present value interest factor annuity lower rate minus present value interest factor annuity higher rate multiplied by higher rate minus lower. This is 15% and this is 16%. This 3.3522 lies in 15% and 3.2743 lies in 16%. So lower rate over here is 15% plus present value interest factor at lower rate, which is 50%, that is 3.3522, and payback period is, we know that 3.3333. we are taking here 4 digit after decimal. Then present value interest factor at lower rate again 3.3522, and present value interest factor as higher rate is 3.2743 multiplied by 16 minus 15. So if we calculate all of this, we get the value of 15.24%. So that means the IRR rate is 15.24 for project A. This calculation is straightforward because there is a even number of cash flow for project. Now for the project B, as we know that the cash flow is different, 1000 in year 1, 2000 in year 2, and so on. So in this case This is uneven cash flow. Uneven cash flow of project. Now let's follow this step. Step 1, calculation of fake payback period. Calculation of fake payback period, that is still fake annuity is equal to total cash flow over project life divided by project life. So that means total cash flow over project life is, let's simply add up all of this amount. 1,000 pound, 2,000 pound, 3,000 pound plus 5,000 pound plus 6,000 pound, and project life is, we know that 5 year, that we 17,000, and number of years 5 years. In this way we get 3,400 per year. And fake payback period, that means again over here we'll use the formula for initial cost divided by annual CF method here. So initial cost is, we know that project B also pound 10,000, then annual cost cash flow is 3,400. In this way we get the fake payback period of 2.9412. Step 2, finding discount rate at trial. Finding discount rate at trial, that means if you look in the financial table, the present value interest factor, this 2.9412 year with a number of years 5, you will get the value. This 2.9412 lies between 15%, which is 2.9606, and 16%, which is closest to this fake payback period 9412. So step 3, adjustment of closest discount rate. Since cash flow of project B in earlier period are less than average cash flow of the project, we try at lower rate than 20% rate. So let's try with 15% discount rate. Calculation of net present value of project B at 15%. That means here 1, 2, 3, 4, 5. Cash flow is 1,000, 2,000, 3,000, 5,000, and 6,000. Present value interest factor annuity at the rate of 15%. We get the value here 0.8696, 0.7561. In year 3 we get 0.6575. Year 4 we get 5718, and in year 4 and year 5 we get 4972. We get the value here, present value, interest factor. We get here present value like this. If you calculate these two, you will get 8696. You will get the value of 1512. Then if you calculate 3000 by 0.6575, you get 1972.5. Multiply 5000 by 0.5718, then you get 2859.00. Then finally, if you calculate 6000 by 0.4972, you will get 2983. How much? 2. If you add up all of this, you will get total present value of pound 10,196.5. And how do we find out the net present value? Initial cost. That means 10,000. We get net present value is 10,000 minus by 10,196.5. So we get only 196.5. Net present value of project B discounted at 50% is 196.5. It indicates that IRR is slightly higher than 15%. So let's try with 16% discount rate. The present value discounted at 16% are given as follow. So again let's try 1 2 3 4 5. Cash flow are 1000, 2000, 3000, 5000 and 6000. This time we are trying present value, interest factor, annuity at 16%. We get 0.88621. In year 2, 0.7432, 0.6407. Year 4, 0.5523. In year 5 you get 0.4761. Then we get here present value. If you multiply 1000 by 0.86, you will get 8621. This is pound. 2000 by 0.7452, you get 1.86.4. Multiply 3000 by 0.67, you will get value of 1922.1. Multiply 5000 by 0.525, you get 2761.5. Let's multiply finally 6000 by 0.4761, you get 2856.60. let's add all of this. Total present value is equal to how much we get? 988 8.7. Initial cost was, this is also 10,000 pound for project B as well. Then we get here net present value as negative by how much? 111.30. Step 4 shows that IRR for project B lies in between 15% and 16%. So let's find out the IRR using this formula. So the formula here is IR is equal to lower rate plus present value at lower rate, cash flow 0, present value lower rate minus present value higher rate multiplied by higher rate minus lower rate. So let's put all of this value. Lower rate is 15%, present value at lower rate is total present value for is 10,196.5, and cash flow is, obviously we know that the initial cost is 10,000 multiplied by present value at lower rate again is 10,196.5, and present value at higher rate was 19,888.7. 9888.70. In this end 16 minus 15 multiply, so we get the value finally here is 15.64%. Decision: IRR of project A is 15.24% and project B is 15.64%. The cost of capital is 10%. IRR for both project A and B is higher than the cost of capital applicable to the project. So both projects are accepted if they are independent projects, and project B is accepted if they are mutually exclusive. Very famous method which is known as modified internal rate of return, or in short it is called MIRR. We have a formula to calculate MIRR, that is COF T divided by 1 plus K power T is equal to n summation T is equal to 0 CF CIF 1 plus K power n minus 1 divided by 1 plus MIRR, where COF T is equal to cash flow or investment in project for fifth year. K is equal to cost of capital, N is equal to project life cycle, and CIFT is equal to cash flow, cash inflow year. So we have a step here. Step 1, we have to calculate the terminal value or TV. How do you calculate TV? We get TV and summation t is equal to 0, that is CIF t 1 plus k and minus t, or this equation can be expressed as TV is equal to CIF 1 plus k power n plus CIF 2 plus 1 plus k n minus 2 plus CIF n 1 plus k power n minus n. Step 2, calculate present value of cash outflow. Get present value by the formula, and summation t is equal to 0 COFT divided by 1 plus k power t. Then step 3, solve the equation for MIR. That means present value COF is equal to terminal value CIF divided by 1 plus MIRR power n. No initial investment, then we get CFO is equal to TVCIF divided by 1 plus MIRR n. Decision rule. If MRR is greater than the required rate of return, we accept the project, and if MRR is less than the cost of capital, then we reject the project. So let's take one example here. So we have a problem here. The first step is calculate the terminal value of project. So in step 1, calculate terminal value. How do it? 1, 2, 3, 4, 5. Cash inflows. Cash inflows is in pound. So let's give the we have for year 1 it is 1,000. 1,000, year 2 2,000, year 3 3,000, year 4 5,000, and year 5 it is 6,000. And we are looking here is present value interest factor annuity at 10%. In this case will be taken the future value of cash flows. So for the MIRR, the future value of cash flow is considered. That means future value interest factor annuity is 10% n minus t, and future value 10% n minus t. This is the formula. If you find out, it is 1 plus rate of return is 10%, and number of year is 5 year, and T is equal to this is T, number of year is T. Don't it's quite confusing, but don't be confused, so we just deduct 1. So that means we get here 1.64, 1.4641, or this one 1 plus 0.1 power 5 minus 2. We get value here is 1.3310. In year 3, same, 1 plus 0.1 power 5 minus 3. We get value here is 1.2100, and year 5 we get 1, 2, 3. For year 5 we get here is 1 plus 0.1, 5 minus 4, that is we get the factor is 1.100, and final year we get 1 plus 0.1, 5 minus 5. So that means we get here 1.00. So if you multiply 1000 by these factors, let's multiply this factor by the cash flow inflows. We get the future value is 1464.1, and year 2 2662, and 33630, year 4 55500, and year 5 we get 6000. In this way, terminal value of inflows is the summation of all of this, that is 19256. Now step 2, calculations of present value of cash outflow. A present value of cash outflow, since there is only one investment outlay in the form of initial cost, the present value of cash flow is the initial cost. So that means thus cash flow 0 is equal to pound 10,000. Step 3, we do solving equation for MR. Is 10,000 is equal to terminal value of cash inflows is 19256, then 1 plus MIRR power n. Let's solve this equation. We get 10,000 multiplied by 1 plus MIRR, number of years we know that 5, then we get here 19,256.10. 1 plus MIRR power 5 is equal to 19,256.10 multiplied by 10,000. 1 plus MIRR power 5. If you multiply 19,256 by 1, this we get 1.9256. Let's solve this problem with the help of law of indices. Law of indices is, we know that we can manipulate this equation like this: MIRR is equal to 1.9256, like this one, then 1 plus MIRR. We get the power here 1.9256, 1 divide by 5, you will get 0.2. So you will get here value of MIRR is 1.140. Let's solve this. So we get MIRR is equal to 1.140 minus 1. Finally, the rate 0.14. So our MIRR rate is 14. Now let's make a decisions. The MIRR rate is 14% and the cost of capital is 10%. So clearly the MIRR rate is greater than cost of capital, then we accept the project. So finally, let's have a look the merits and limitations of modified internal rate of return. MIR has fundamentally two merits over IRR. First, it is based on the assumption that the cash flow are reinvested at cost of capital. This assumption is more realistic than assumption of regular IRR. So MIRR is a better indicator of profitability of the projects. And second, it solves the problem of multiple returns. As stated earlier, multiple rates of return problem arise in the project with non-normal cash flows of project, but MIRR solves this problem by converting the present value of the cash outflows and terminal value of the cash inflows of the projects. Thus, MIRR overcomes the multiple returns problems of regular IRR and unrealistic assumptions of reinvestment of cash inflows generated by the projects. The limitations. In spite of merits stated above, MIRR has some limitations. They are: first, net present value and MIRR of mutually exclusive projects gives the same decisions provided the size and life of the project are equal. But net present value and MIRR gives the conflicting decisions when decisions differs in size measured in terms of investment. So second, it is a little bit difficult to understand the calculation process of MIRR, since first cash outflows and inflows are converted into present value and terminal value respectively, and then based on the present value of the outflows and terminal values of the cash inflows, MIRR is calculated. It's quite confusing. Profitability index, the last methods of capital budgeting. What is profitability index and how do you calculate the projects? Is profitability index is equal to total present value divided by initial costs, or PI is equal to N summation T is equal to 1 cash flow T 1 plus K power T divided by whole divided by CF0. And the decision rule is straightforward. Decision rule is if profitability index is greater than 1, accept. If PI is less than 1, then reject. PI we calculate for project A by net present value plus initial cost divided by initial cost. The net present value for project A is, we have already calculated. If you want to have look, go back of this lecture, of this video, you get 1372, and we know the initial cost is 10,000 and 10,000. Total is 11,372 divided by 10,000. We get the value is 1.372. The decision rule: if PI is greater than 1, we accept this. So we get the project PI is 1.02, so we accept the project A. Let's have a look for project B. For project B, net present value plus initial cost divided by initial cost. Net present value for project B is 1956. Initial cost is obviously we know that 10,000 pound. 10,000, we're going to say 11,956 divided by 10,000. You get 1.1956. This is also have got greater than 1, so we accept project B as well. So we both accept project A and B because the value of profitability index is greater than 1. Now let's have a look the merits and limitation of profitability index. This method also has the same merits and limitations of net present value technique, but in addition to the merits of net present value, it has one more advantage. It shows the relative profitability of the project. As stated earlier, it indicates the net present value per pound of initial cash outlay.